All right, let's talk about center. Okay. Remember, shape, center, spread, anything weird? Okay. What does it look like? Where's the middle of it? How spread out is it? And is there anything weird or unusual? Okay. Well, a way to talk about center is what this page is going to refer to. The center is the mean. We all already know how to find the mean. That's our grade in the class. It's an average. So to find the mean, we're going to take every value, we're going to add them all together until we've done that for every single data point, and then we're going to divide by how many there were. But we need to look fancy in statistics. So this is the formula you'll see on your formula packet. This formula will be given to you to use on the AP test. So this symbol right here is called the summation. Okay? So it's the summation of x sub I over n. Anytime you see this some variable sub I, it's saying take every individual. So this formula up here is the same as this one down here. They are the exact same formula. This says the summation of x sub I over n, which says take every individual x, summation, add them all up, and divide by how many there were. That's how we find the mean. That's one way that we can find the center. Well, when we're talking about mean, if we calculate the mean, we're going to use this term instead. That's going to be the symbol for mean. That is what we're going to call X bar. X bar is a sample mean. It's the mean that we calculated from a sample set of data. Another way to talk about the center is the median. And the median is simply list all the numbers in order and find the one in the middle. So let's say I had 3, 5, 7, 7, 9, and 11. Where is the median? Well, the middle, oh, it's right there. So it's halfway between 7 and 7, which is 7. Okay, so the median is put the numbers in order and find the middle number. Now we're going to talk about this term resistance. Is it a resistant measure? A statistical measure is said to be resistant if it is not sensitive to extreme values. So if we look at a simple data set, let's say 2, 5, 6, 10, and 12. Okay. What would the mean be? Well, add them all up, 7, 13, 23, 35. So the mean, sample mean X bar would be 35 divided by 5, which would be 7. What is the median of this data set? Well, it's the middle. Where is the middle of this data set? 1, 2, 1, 2. Oh, the middle is 6. So the median would be 6. What do they mean resistant? Are you resistant to extreme observations? So let's say that this 12 is turned into a 102. Well, the median is still 6. The median is resistant to this extreme observation. Do you think the mean is still 7? I doubt it. We add these up, 13, 23, 125 divided by 5. Uh-oh. 25 is not the same as 7. So the mean is not resistant to extreme observations. It is sensitive. The effect of skewness and outliers on measuring the center. Okay, so if we have skewed data, the center is going to be towards the skewed side, obviously. Okay? If the data is symmetrical, then the mean and median will be the same. And if the data is skewed, the mean and median will both be towards the skewed side. Okay, what we need to understand here is that the mean is always on the skewed side of the median. The mean is always on the skewed side of the median. So if we look at example A, the median is at 19. But since this data set is clearly left skewed, I know the mean will be to the skewed side of the median. In dot plot B, the data is symmetrical. Therefore, the mean and median are roughly the same. And in dot plot C, the data is strongly right skewed. So the median's at 2, but the mean is out here at 3.15 because the mean is always on the skewed side of the median. Why? The median is resistant to those outliers. It doesn't really affect the median, okay? But the mean is not resistant. Therefore, it is pulled or dragged towards that skewed side. Well, how are we going to talk about spread? Okay, so we've talked about the shape. Is it symmetrical or is it skewed? We've talked about the center. Is it the mean or is it the median? Well, let's talk about the spread or the variability. Okay, the range, simple. Take the smallest number and the largest number and subtract them. So if we look at this example over here on the right, what would the range be? 6 minus 1? Oh, the range would equal 5. Simple. That's one way for us to talk about the spread. Usually when we're talking about skewed data, we'll use the range to describe the spread. Now, this term here, we're going to have to spend some time with. Standard deviation. What is the standard deviation? It measures the typical distance of the values from the mean. So standard deviation is, on average, how far is each value from the mean? So it's the mean distance each number is from the mean. On average, how far away is each value from the mean? Here is the cool looking formula for standard deviation. Notice here on a couple of these slides, you'll see a red line going through something. When this book was converted over to the digital form, some of the information got messed up. So as you're reading through the book and as you're looking through these slides, just ignore anything that you see with a red line. You won't see this red line in your book, but notice that it will show up on these slides and you can relate that back to your book. Okay. How to calculate the standard deviation. Okay, so we take each individual x. Okay. If we look at this formula here, take each individual x minus the mean squared, plus the next x minus the mean squared, plus the next x minus the mean squared, until we've done that for every single data point. Okay. Then we find the summation of all those squares divided by n minus 1, and then we square root that. Okay, so there's something else we're going to talk about, which is the variance. We won't get too much into the variance right now, but that's supposed to be an I, but it doesn't look like it. The variance, let's try this again. Variance. Okay, the variance is just the square of the standard deviation. So the variance would be s squared. Notice the notation for standard deviation is s of x. That's the standard deviation for a sample. Well, standard deviation for a sample of data that we collected. So this formula, the standard deviation of x is equal to the square root of the summation of x sub I. Remember, x sub I means take each individual x minus the mean squared over n minus 1. So why would we take a distance and then square it and then square root it at the end? Because we're trying to find how far it is. Remember, a standard deviation is measuring a distance. And we can't have negative values. You can't say you're negative 3 feet tall. You can't say you live negative 10 miles away from school. It doesn't make sense when we're measuring distances to have negative values. So that's why we're squaring these to get all these distances positive. So what do we do to actually calculate the standard deviation? Remember, we're going to find the mean of this data set. So we would add all these values together and then divide by how many there are. And that would give us the mean of the data set. So this 11 high school students were asked how many close friends they had. So we can see that this data is quantitative. How many close friends do you have? You answer that with a numerical value. Therefore, this is quantitative data. So if I were to take all those numbers and add them up, I would find that my mean X bar is equal to 3. Now, to find the standard deviation, I have to take each one of these values minus the mean. So I have to take 1 minus 3, and then I have to square that. And then I have to take the next one, 2 minus 3, and square that. And then I take the next one, 2 minus 3, and square that. And then I take the next one, 2 minus 3, and I square that. And I do that for every single data point. After I've done all of these subtracting and squarings, I'll add them all together, and then I'll divide by n minus 1, meaning one less than how many data points there are. So after I did that and I squared all these, for example, this would be 4 plus 1 plus 1 plus 1 and so on. After I did all that, I got 18. And then the formula says now divide by one less than how many there are. So there's 11 data points here. I would divide that by 10. That would give me 1.8. But I'm not done, because the end part of this formula says now take the square root of that value. So I would take the square root of 1.8 to find my measure of spread, or my standard deviation. I do not know what the square root of 1.8 is, but that's okay, because I can do that here. So I'm going to do the square root of 1.8. Whoops, it helps if you put the decimal in. The square root of 1.8 equals 1.34. Okay, so my spread, or my standard deviation, is 1.34 for this example. What did I find out? On average, each person is 1.34 friends away from the mean of 3 friends. That's what the standard deviation is telling us. Okay. Another way to talk about spread would be what we're going to talk about as quartiles, or we're going to break the data set up into 4 equal parts. Okay. There's a first quartile, a third quartile. We already talked about the median, and we already talked about the minimum and the maximum. So the first quartile is the median of the first set of data points. So for example, let's look at this soccer problem here. Where is the median? Remember, it's the middle. So I got to count, where is it? Oh, there's 20. So the median would be halfway between the 10th and 11th. Let's see. I'm going to do this on both sides to find the median. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10. Oh, there's the median. Okay, so now I found the median lives right there. Let me erase this so it doesn't look all junky, but that's what I do, is cross them out or circle them, one on either end, so it's easy for me to find the median. Oh, the median is halfway between 2 and 2. Oh, the median's 2. Because it's halfway between 2 and 2. Okay. Now, the first quartile, Q1, is the median of the first half of the data. So let's cover this up, and let's find the median here. Let's do it again. Where's the middle of the first half? Oh, it's right there, halfway between 1 and 1. So my quartile 1 equals 1. All right. Well, what if I want to find quartile 3? It's the median of the second half of the data. So remember, there's the median, there's the median, and Q3 is the middle of the second half. So Q3 would be, let's cross them out again. Where's the middle? Oh, it's halfway between 4 and 5. Oh, that's 4.5. So my third quartile would be 4.5.